Hello, today we are doing a little science experiment, and if you guys want to do this yourself, you're going to need like a plate or a bowl or something, just a little bit of milk, some dish soap, and some food dyes, and then something to dip the dish soap. So basically what you do is you put tiny little drops of the food dye into the milk, then you take your little stick thing, you dip it into here, and then you do this. And they will like spread apart.
Whoa.
And eventually they'll go through underneath, like it goes a little underneath the milk and it comes out right there. So I don't know if my phone will pick this up, but if you look really closely, like Mom, you could probably see this. It doesn't, like, the fats in the milk are the same, have the same as the dish soap. So basically, when the fats, they're both polar, so that means they're both positive. Like with a magnet, if you take two of the same sides and you put them together, they'll try to go apart. Unless you do opposite sides and they'll go together. If you do two of the same sides, they'll go apart. So basically, let's say like the milk is positive and then the dish soap is positive. So basically, those two are pushing each other apart. So the food dye, as soon as it touches the milk, it bonds with the fats. So basically you have colored milk and it can't go apart unless you add one of the same things. So like if I added more food dye onto here, if I added food dye into the stick, it would break apart the other food dye and replace it with that food dye. So eventually, unless you do this, it will stop working. If I do that, it looks really cool, but eventually it'll stop working because all of the fats will have bonded. But otherwise, if you want to make a really cool painting, this will work perfectly fine.
That's really neat.
Yeah, just be very careful not to like dip your arm in it. Like I almost did that just then. And also try not to spill it because milk and food dye will get everywhere. And you might want to wear gloves too, because like if I like dip my finger in there like that, see, it might make my finger blue. I need a napkin now. Yeah. It's all for the content. Yeah, but like you can make all sorts of cool stuff. You can use any color you want. Just like it has to be food dye, or even when I first learned of this, it said you should experiment with it and use pen ink. But you're gonna make a mess if you do, so I don't recommend it, unless you just to clean it up. Yeah, like as you can see in like other areas, like it's kind of moving around, but like even after you do it, it starts to move around a little bit more because the fats are still actively bonding with the dyes are actively bonding with the milk.
That's really cool.
Yeah.
So if one of them was negative, it wouldn't do that.
No, if both of them were negative, it wouldn't do that.
Oh, what if one was positive, one was negative? Do you know?
If one was positive, one was negative, that's what's happening here. The
milk, I thought you said it was positive.
The milk would be positive because of the fats, and this would be these would be negative. So they bond together like this. So that's why when I do that, it moves around the food dye. But why it's a little delayed? Like when I do that, it's a little bit delayed from when I actually touch it because it's not fully bonded. So like the way you can test to see if it's not fully bonded yet is like sticking it back in here. We're gonna need more dish soap here. You stick it back in. Yeah. So if it keeps moving, it's not fully bonded. Mine is almost fully bonded, so it's not going to work as well. But you can add more food dye in if you want to.
That is really interesting.
Yeah, so you got to be careful when you're like throwing it out, but if you have the right type of plate, it'll look really cool because once you dump it off, your Mom just follow me to like the sink. I'm gonna be careful here. Oh shoot, that's not gonna work.
You take this and I'll take that.
Okay, let's do it because it's going to be. Yes, we are, and it's going to dye. Just be careful when you do it. It's going to dye the paper plate, and it'll look really cool. Don't wash off the paper plate because that looks really cool. Sorry about that, guys. I had to drop something. So yeah, it looks really cool when you're done, and you can even keep it. It'll take a bit to dry. Hold on, you gotta just do a little bit more.
Like milk, although they got the down dish soap.
Yeah, so it'll smell like your dish soap or like your milk, depending on how much dish soap you put in, or how much milk you put in.
Don't pour that other. I can use that tonight. That dish soap, unless you want to do it again later.
No, I'm thinking we should pour it out because there's milk in it. But, anyways, so yeah, it should look like around this when you're done. But yeah, it's just a really cool science experiment to do, and you can like do it on canvas too. But you're gonna have to put stuff up around the canvas, and then you'll get this really cool colors. Now, this is like some painters, they've actually made paintings like this. But anyways, I have a whole paper on it, so I'm just going to cut and explain it really fast. Okay, so this is like the whole explanation. I got my whole thing here. But so, yeah, when you're done, you end up with this. That's what we ended up with. But so, here's the explanation. So milk is mostly water, but it also contains vitamins, minerals, proteins, and little droplets of fat suspended in the solution. Fats and proteins are sensitive to changes in the surrounding solution, which in our case was the milk. So basically, when it said tiny droplets of fat suspended in the solution or in the milk, that means so when it looked like it was going under and coming back up where the dish soap was, like right in the middle maybe. That's because it was floating and it was moving around at the same time, looking for little molecules of fat to bond with. So that's why it came back up through, because it just ended up there and it went back out again. So it was really cool. So the secret of the bursting colors is in the chemistry of that tiny drop of soap. So like other oils, milk fat is a non-polar molecule, so that's negative. So that means it doesn't dissolve in water. So when soap is mixed in, the non-polar, which is a hydrophobic portion of, I don't even know how to say that word, but I would say Michelle's. Which is it's molecular soap structures in solution. So basically, like dish soap is just like a version like these little pieces of soap bonded with some other stuff. But so those shell things, they break up and they collect all the negative fat molecules or the non-polar ones. So then the polar surface of the Michelle, which is a hydrophilic or the positive, connects to. Are you pointing the camera at Mom?
Mm-hmm.
Okay, sorry about that. So then the positive, the hydrophilic, connects to the other positive water molecule with the fat held inside of the soap Michelle. So thanks to the soap connection, literally the non-polar fat can then be carried by the positive water. So basically, like a magnet, if you had two magnets, you had the negative and the positive side, and you connected them, you could drag them like that. That's basically what's happening. So it is it's the fat is the negative part, and the water in the milk is the positive part. So it's being carried by the food dye, which there is water in food dye. So when it's being carried by the food dye, that's basically the positive, and the milk is the negative. So it's like dancing around basically. So then that's where the fun begins. The molecules, the fat, it like bends and rolls and twists. So that's why it started to look like that. And like they'll like contort and all that. And in different directions, the soap molecules, they race around to join up with the fat, just like these. So that's why it made such a negative, like a bursting reaction. Then, during all this fat molecule gymnastics, the food coloring molecules are bumped and shoved everywhere. So that's why it shot out from the dish soap. So it went everywhere. So as the soap becomes evenly mixed with the milk, the action slows down and eventually stops. So basically, it's talking about how like heat is basically like heat and cold. So heat, like when something like